Hello and welcome back. Today we're going to take a look at how to create a Progressive Fluent Interface. A Progressive Fluent Interface is a variation on the method chaining approach to creating your Fluent Interface. What makes a Progressive Interface different is that the options which are available or can be used will change depending on the direction that you are heading when you're writing your code. In our example today, we're going to take a look at how we can use our Progressive Fluent Interface to solve a common problem that most applications have: data entity validation. We will start off by taking a look at a current validation logic which is in place, and once we understand the problem we're trying to solve, we will dive in and create a new progressive validation interface. So let's go ahead and get started. The entity that we're going to be validating in our demo today is just a very simple entity called host entity. It has a first name and last name, a date of birth which is nullable, and age which is nullable. Now, currently we have in a what I call a very painful validator. So I have a class that will perform validation, and it essentially does all these if checks one after another. It's just painful to read, and you have to add in all this nested logic here, down here in date of birth. So if it's null, return something. If it's not null, then we have to check for min val and max val. And although this works, it's just painful and very cumbersome. So what we want to do today is create a Fluent interface that will change based on the data type we're trying to validate, and we'll perform validation in a much cleaner and simpler way to the user. Before we start writing some code, let's make sure we have unit tests that will actually perform our validation. So let's go ahead and run this. And I can step over this and I can see that I have two messages I return back. The username was null or empty, and the age was out of range. So right now with the current entity set, I know that I have two errors. Alright, now that we've actually taken a look at the current validator, which is what I like to call the painful validation, let's go ahead and take a look at the validation class that we want to get to in the long run when we have fully implemented our Fluent interface. Let me bounce over to my other class real quick. And I'm going to create a new class here, and I'm going to call it Entity Validator Fluent. I'm going to copy and paste this in order to save time. Now, one thing to pay attention to here is I do have a lot of red squigglies, but that's actually not a bad thing. These are just showing you where I want to get to. We're going to go ahead and fill in all the details here in a minute. But before we do that, let's take a look at what we want to create. I want to create something that basically allows me to say validate that, and a property name is not null or empty. Or and if it was a date field, validate that a date field is not null, is not greater than today, or possibly is not min max val. Or I could add on any other validations as I want, and I can chain them in any manner, any order which I want. So how do we get started with this? Let's go ahead and we're going to create an interface here that's going to be our individual per property validator. It's going to be called iValidator result. Let's go ahead and copy this in here as well and take a look at it. Our validator result has three fields. A is valid, which will tell us whether it's valid or invalid. The message, now this should be an empty string if it is valid, and the field name in which we're validating. Now we're going to want to go ahead and create a base class to derive from this interface. We'll make this as public and we'll call this base validator. And base validator implements the three fields from the interface, as well as has a method on it called setFailure. SetFailure will take a string and will internally set the validation message, as well as flip the bit flag to false. Let's go ahead and move this to its own class. Now that we've actually created our individual per field validator, let's go ahead and create our base validation that'll validate our entire object. So I've created this class called base validation. And base validation will be a base class that all my entity validators should inherit off of. And this will allow me to provide functionality that I want everybody to have. Let me collapse some of the stuff here so we can take a better look at what's going on in here. I have a method called reset. This will actually be used to clear out all my existing validations. That way I can start over from a clean slate. I want to provide the number of violation count, so simply how many failed, my raw violations, a boolean to tell me if I have any violations. This will be a simple bit flag, yes or no. And then here you'll see I have something called placeholder for validators. We'll get to that here in a second, but this is actually going to be part of our Fluent syntax. Now, if we bounce back over to our our class here, you can see that now I've started to implement a bunch of my code from my class. I have my base validation class. I've implemented reset. This will essentially clear out everything. And I have my validate, but what I'm missing right now is that. That is where the progressive part of this interface starts to come in. Because what I'm going to be able to do is say validate that, and then depending on the type of field, whether it's an integer or a string or a date time or whatever, the various pieces that follow that will change. So that's what we actually want to go ahead and create right now. Now let's go ahead and bounce back over to my base validator. Let's go ahead and bounce back to my validation class, and I'm going to go ahead and paste in a bunch of the validation keyword that I want to create. Now you'll notice I get a bunch of squigglies here, and that's fine because I need to actually go ahead and create all my individual validators. The validators I want to create are my date validator for both a non-null and a null field, my string validator, and then integer validators for both null and non-null as well. And if we take a look at this, they're very simple and very straightforward. All I'm going to do is create a new instance of it. I'm going to pass in the value which I'm trying to validate and the field name which I'm trying to validate. And we're actually going to add that to our validation results list right then and there so that we always have that in memory. And I'm going to go ahead and return the instance that I just created. This is what's going to allow me to progressively change the interface as I determine which data type I want to perform validation on. Now, because I have a lot of code in my date, string, and integer validations, I'm going to go ahead and just include those, and then we'll take a look at these once they've been included. So I've gone ahead and I've included the date validator. So let's go ahead and bounce over to date validator and see what it's doing. As you can see, because I'm able to validate both a null and non-nullable field here, I've got two constructors that are overloaded, and then I've got my three validation methods that are part of my interface. Is not null, is greater than today, is not greater than today, and is not min max val. And you'll notice that each of these validators return itself back to the caller. This is what's going to allow me to continually chain one after another, one after another. And if we take a look at the meat of any one of these validators, they look very similar to the old if logic that I had in my validation class that I called my painful validation class. But now, since they're encapsulated away, each thing is a very small unit, and if something goes wrong, it's very easy to figure out what it is. But it also gives me a much cleaner interface to my user on the front end. And just for giggles, let's go ahead and take a look at the integer validator. And you'll see that it looks very similar. I've only implemented a not less than. I could obviously implement a not greater than or not equal to, or whatever the case may be, not within a range. So now we bounce back to our Fluent validation. You'll see that I can do validate that, field name, and then a string here. And the string is optional, or could be optional in your case if you want it to be. I chose to make it mandatory. And it is not null or empty. So what does this look like when I'm actually building? So I can use the keyword that. You'll notice that that has many overloads. That's what's actually allowing me to make this progressive. So I could put in a string here. If I filled it in validly, it is not null or empty would pop up. If I put in an integer here, is not less than pops up. So as you can see, here's a progressive nature. So now we've created our progressive interface. Let's go ahead and create a unit test here. So let's go ahead and paste in the new unit test we want to create. So this unit test basically has the same host entity that we implemented before, the exact same values. I'm going to create an instance in my validator class using my Fluent interface. I'm going to basically call off into my class and say perform validation, and it should return back a Boolean whether or not I have violations. So now I've come back, and sure enough I do have violations. And let's take a look at my violation results, and I can take a look one by one. And first name is valid. Last name is not valid because I didn't have an empty string provided. Age is also not valid because it's below the min val. And then date of birth was valid. So as you can see, in about 10 minutes, we've gone ahead and created a progressive Fluent interface. Let me bounce back to that real quick so we can take a look at it. We've created a progressive Fluent interface that, if you ask me, vastly reduces the amount of noise. Here's the old validator, a bunch of if statements, one after another. And here's a very simple, reusable validation that is very clean and concise. And if my rules change or I don't want to validate that it's not greater than today, that's all I do. I need to add a new one on, I simply build a new one. And I can just continually chain these one after another. And if I want to change or add a new type, so let's say I want to change it to a double. I want to create a new validator that's on type double or float, or even my own custom type, I could do that as well. This will allow me to chain these things endlessly and very simply and very easily.